We will start off with WSJT, designed by Joseph Taylor K1JT, Nobel Prize winner in physics, and the extended version WSJT-X, followed by what is WSJT in amateur radio and meteor scatter, what is PSK Reporter in amateur radio, what is FT8 Mode in amateur radio, Whisper in amateur radio with 10 milliwatts, and International WSPR Beacon Project. Welcome to my tech world. WSJT is an amateur radio program which can be downloaded free from the website. It was designed by K1JT initially and published in 2001. Later it was expanded as an open source program with contribution from many others and has been called as WSJT-X. Currently it is a 2.6 version which is available and it has 11 modules. Of these, FT8 seems to be the most popular. WSJT is a software program for weak signal radio communication in amateur radio, initially written by Joe Taylor K1JT. WSJT-X is a later open source program with digital signal processing techniques developed by a small group. WSJT-X supports special propagation modes like high-speed meteor scatter and moon bounce. WSJT also sends signal reports to spotting networks like PSK Reporter. FT8 is available in WSJT-X since 2017. Meteor scatter is a special mode in which the ionization of atmosphere produced by the meteor trail refracts VHF and sometimes UHF signals so that long-distance communication is possible without repeaters. But it is a transient phenomenon and requires special setup. High-speed Morse code and FT8 are the modes of communication used for meteor scatter. Short communications are possible during large meteor showers. In high-speed Morse code, earlier it was pre-recorded in tapes and speeds enhanced by fast-forward. Computers can do the same now more easily. JT5 was designed for EME or moon bounce on VHF and higher bands. Q65 is for tropospheric scatter, transequatorial propagation, and other types of fast fading signals on VHF and higher bands. Echo is meant to detect and measure your own station's echo from the moon and optimizing performance on EME. WSJT-X installation packages are available for Windows, Macintosh and Linux. An interesting feature in WSJT-X is that there are features supporting the ARRL International Digital Contest and its distance-based scoring. It can select the reply to your CQ call that yields the most contest points. For using WSJT-X, you need an SSB transceiver and antenna along with a computer. Monitor resolution should be at least 1024 x 780 pixels. Computer to radio interface is using a serial port or equivalent USB device. Audio input and output devices supported by the operating system are needed. There should be a means for synchronizing the computer clock to UTC within ±1 second. PSK stands for Phase Shift Keying Modulation. It is a digital amateur radio mode most commonly used in HF and sometimes at higher frequencies. PSK Reporter is an amateur radio signal reporting and spotting network. The website was started by Philip J. Gladstone N1DQ in 2014. It is named as DigiMode Automatic Propagation Reporter. The website shows a dynamic map of the world where the receivers and transmitters of PSK are at any given moment. It allows amateur radio operators to see where their signals are being received. Though it supports other digital modes as well, most of the traffic currently registered are from FT8 mode. When I checked at 5:40 am IST on 16 Jan 2023, I could see 5 amateur radio stations monitoring from South India and 5959 active monitors worldwide. Highest frequency being monitored was 10 GHz with highest number of monitors globally being on 10 meters. The system uses signals transmitted by stations calling CQ and does not transmit any signal. PSK Reporter is useful in determining propagation conditions and for antenna adjustments. It is also useful for ionospheric research about propagation conditions. FT8 stands for Frank and Taylor 8 after its developers Stephen Frank K9AN and Joe Taylor K1JT. FT8 is a frequency shift keying digital weak signal mode used mostly on high frequency amateur bands. It is an 8 frequency shift keying format with tones spaced at 6.25 Hz so that an FT8 signal occupies just 50 Hz. Using advanced signal processing technology, FT8 can decode signals with a low signal-to-noise ratio much better than CW or SSP. Signals are sent in 15-second blocks with 12.64 seconds transmission time and 2.3 seconds decode time. Effective speed will be lower than usual CW at about 5 words per minute. Both transmitting and receiving computers have to be synchronized, typically using automatic online time servers. Each FT8 transmission can support up to 13 text characters. Forward error correction ensures proper decoding despite fading, interference, poor signal propagation conditions, and compromised antennas in urban locations. Due to the limitation in number of words, only minimum information to establish a contact is sent. FT8 mode is likely to be useful in a contest. WSPR or WSPR stands for Weak Signal Propagation Reporter Software for weak signal communication by radio amateurs, again initially written by Joe Taylor K1JT like WSJT. It is now open source, developed by a small team. It is meant for low power test transmission on medium frequency and high frequency bands. Frequency shift keying is used to send short messages which are compressed into just 50 bits of data. The message includes call sign, maidenhead grid locator, and transmission power. A WSPR signal with 5 watts has been compared to 2 kilowatt with SSB. If a WSPR station is spotted with 5 watt with a signal to noise ratio of -29 dB, then that station must use at least 2 kilowatt to make a QSO. A WSPR station with a power of 10 milliwatt can be spotted only if the propagation condition is very good. In that situation, it will correspond to a CW signal of 200 milliwatt power. WSPR station of 10 milliwatt has been received at 1100 kilometers on 7 MHz. WSPR, pronounced as WSPR, stands for Weak Signal Propagation Reporter Software for weak signal communication by radio amateurs. International WSPR Beacon Project aims at deploying 40 WSPR beacons globally, which will transmit same power with same band hopping schedule 80, 40, 20, 15, 10 meter continuously in a synchronized fashion. The exact transmit frequency within the allocated WSPR segment or band is picked randomly by the firmware. Aim of the project is to identify and visualize weak signal propagation paths to study global ham radio HF propagation. WSPR beacon does not need a computer or internet connection but needs a vertical multi-band omnidirectional antenna. RF power transmitted is just 200 milliwatts. There are 2 beacons operating from India. One is VU2OB in New Delhi using GEK 5-band HF antenna and another VU2ITI in Kerala. The WSPR desktop transmitter runs on 5-volt USB with maximum 250 milliamperes usage. Hardware cost is just $139, which is refunded by the project once the beacon is up and running. Potential participants are selected very carefully to achieve best possible global coverage.